in general, for a polynomial, say p of x, we are supposing the polynomial as p of x, polynomial in which the variable as x. So in this polynomial, in case if p of a, that means when in the polynomial p of x and in the polynomial same polynomial p of x, if x is replaced by means of a, then in case if its value is of 0, then the value which we have substituted instead of x, that is a, then that a will be called as the 0 of the polynomial. So that a will be called as the 0 of the polynomial. So here the polynomial we supposed as here p of x, the polynomial p of x. So when we consider a polynomial p consisting the variable x in it, then if x is replaced by means of a, that is p of a value is of 0, then the value which we have substituted instead of x as a, that particularly a will be called as the 0 of the polynomial, since we are getting 0 as the result when in polynomial when x is variable is replaced by means of this particularly this a. So now let us perform one example under this, that is, let the polynomial p of x be x minus 3. Then here we have to find out the 0 of the polynomial. Find the 0 of the given polynomial. Here the given polynomial is of p of x, which is nothing but x minus 3. So here polynomial mean the expression consisting 2 or more terms in it. So here two terms, say this polynomial is consisting 2 terms, the first term is of x and the second term is of 3 separated by means of negative sign, that is minus. Then now to find out the 0, so we have to substitute. Then now solution starts now. In our solution, the given polynomial p of x is x minus 3. So this is the given polynomial. Then at x is equals to, let us substitute first of all 0, let us take some values such as 0, 1, 2, 3, 4 and so on, and let us substitute one after the other. So in case if we get the value of p of that particular value p of x as 0, as the result as 0, then that value will be the value which we have substituted instead of x will be called as the 0 of the polynomial. Then here in the first case, at x is equals to, first case is 0, so I am going to substitute x is equals to 0, but the polynomial is of p of x, then that is equals to, polynomial is given by means of x minus 3, then that is equals to, x must be replaced by 0, so in the place of x I am going to write 0, then minus 3 kept as it is. So we can struck off this 0 since it does not have any value, then that will be equal to minus 3. So in this manner I say I got p of x value as minus 3, but this value is not equals to 0. In order to get the 0 of the polynomial, we must get the result as 0, but here minus 3 is not equal to 0, therefore x is equals to 0 is not the 0 of the polynomial. So here hence zero is not the 0 of the polynomial. Then let us go for the next one, that is the next case at x is equals to 1, whereas polynomial p of x is given by means of x minus 3 by substituting x as 1 in it, so x must be replaced by means of 1, so x replaced by 1, minus 3 kept as it is, then that is equals to 1 minus 3, 3 is of negative and 1 is of positive, so plus of minus is of minus, let us subtract 1 greater minus this, 3 minus 1 is of 2, to assess the sign of this 2, 3 is greater than 1, so 3 sign is of negative, we got minus 2. So in this manner I say I got p of x value as minus 2, which is not equal to 0. So here also, so here hence this minus 2. So here this 1 is not the 0 of polynomial p of x. So in this manner 0 is not the polynomial, so 0 is not the 0 of the polynomial, and similarly 1 is not the 0 of the polynomial. So let us go for the next value, that is at x is equals to 2. The polynomial is of p of x is equals to x minus 3. When we replace x by means of 2, that is 2 minus 3 kept as it is, then that is equals to 3 is of negative and 2 is of positive, plus or minus is minus. Let us subtract 3 minus 2 is of 1. So 3 sign is of negative, because 3 is greater than 2. So 3 sign is of negative, then the assessed sign will be minus. So in this manner I say I got p of x value as minus 1, but which is not equal to 0. So here hence, so here 2 is not the 0 of the polynomial p of x. So similarly let us go for the another number, that is at x is equals to 3 now. Then the polynomial, given polynomial is of p of x, then that is equals to x minus 3. Then let us replace this x by means of value 3. So here x replaced by 3, minus 3 is equals to 3 minus 3 is of 0. So here therefore p of x is equals to 0. Hence this x is equals to 3. Hence x is equals to 3, or simply what I say 3 is the 0 of the polynomial. So it is nothing but the 0 of the polynomial p of x. So in this manner, so we got 3 as the 0 of the polynomial. Then now when the linear polynomial mean the variables degree will be of 1, then its 0 also will be, then it has only 1 and only 1 0, because the linear polynomial degree will be of 1. Therefore linear polynomial will have only 1 and only 1 0. So here the note is a linear polynomial. Linear mean the degree of this variable x to the power of, so here x variable's degree is of 1, so it will be called as a linear polynomial. A linear polynomial has one and only 1 0, because the degree of variable in it, that is variable in the linear polynomial is 1. Since the variables degree is of 1, therefore that linear polynomial will have only 1 0. Then let us go for one more example, that is example number 2. Here let us find the zeros of the polynomial that is polynomial is given by p of x is equals to x square minus x minus 2. So we have to find out the zeros of this polynomial given by means of x square minus x minus 2. Say here this polynomial is consisting 3 terms in it. First term is of x square, then second term is of x, and third term is of 2, and here they are separated by means of minus signs in between. So here x square coefficient is of 1 in the first case, the next coefficient is of minus 1, and the constant is of minus 2. So we have to find out the zeros of the polynomial. The degree of the variable is of x, the degree of the variable is of 2, so it has 2 zeros. Since the highest degree of this polynomial is of 2, therefore this polynomial will have the 2 zeros. So here the solution starts now. In order to find out the zeros, so the polynomial given is of p of x, then that is equals to x square minus x minus 2. So in this, the degree of the polynomial, so degree of the variable or degree of the polynomial is the highest degree of the variable. The highest degree variable is of x, the variable's highest degree is of 2, therefore the degree of the polynomial is also 2. Then therefore or hence this polynomial, or it has two zeros. So let us solve for those two zeros. So here p of x is given by x square minus x minus 2. So x coefficient is of minus 1. So let us find out the factors of this. I say here we will be getting two factors. So in order to get the factors, let us go for the cross multiplication method. Then x square is the first term. So here since x square is the first term, so by splitting it into the two forms, that is x into x is of x square, and the last term is of 2. Let us split this 2 as 2 ones are. It's 2. By cross multiplying, 2 into x is of 2x, then 1 into x is of 1x. 2 into x is of 2x and 1 into x is of 1x. To assess the sign of the middle one, we need minus 1x in the middle as the middle term. To get the middle term, that is minus 1x, we need minus sign. So among these two, the greater one is of 2. Let us attach the minus sign to it first of all. To assess the sign of this next one, that is 1x, so here we have to see whether the value is of minus 1x or not. So if it is of plus, so here minus into plus is of minus, we have to subtract 2 minus 1 is of 1x. Then among 1 and 2, 2 is greater, its sign is of negative. So minus 1x is the middle term. So 2 must be attached minus sign, therefore 2 must be attached here minus sign. And 1 must be attached positive sign, so 1 is attached positive sign. In order to write the factors, we have to write horizontally, that is x minus 2 as the first factor and x plus 1 as the second factor. So in this manner I say I got, therefore, so here expression that is p of x, that is x square minus 1x minus 2 can be written as the two factors, one factor as x minus 2 horizontally and the other factor as x plus 1 as the other factor. When we multiply these two factors, again we will be getting the same x square minus x minus 2 as p of x. So in this manner I say I got p of x as x square minus x minus 2, which is equals to x minus 2 and as well as x plus 1. But in order to get the 0 of the polynomial, so we have to equate the p of x to the 0. So here by equating, that is p of x to 0, in order to find the 0 of the polynomial. Then we have this polynomial p of x, that is nothing but x square minus x minus 2, or in other words x minus 2 into x plus 1 must be equated to 0, So here in order to find out the 0 of the polynomial, then we have, so here p of x, that is equals to x square minus x minus 2. Instead x square minus x minus 2, it can also be written as x minus 2 into x plus 1. So since we are finding the 0 of the polynomial, so we have to equate p of x to the 0. So this p of x must be equated to 0. That implies x minus 2 and x plus 1 must be equated to 0. That is, either x minus 2 must be equated to 0 or this x plus 1 must be equated to 0. Since x minus 2 is equals to 0 or x plus 1 equals to 0, to find out the x value, we have to transpose this 2, which is of negative, on the other hand. The 0 won't have any value, we can cancel up minus 2. When it is transposed to the other hand, it becomes plus 2. Or x equals to plus 1 is on the left hand side, when plus 1 is transposed to the right hand side, so we can strike off the 0, and plus 1 when it is transposed to the right hand side, it becomes minus 1. So in this manner we got x as 2 or x as minus 1. So these two are the values of x, which are nothing but the zeros of the polynomial. So hence 2 or minus 1 are the zeros of the given polynomial.